Hey everybody, we're going to start chapter 4 today. We're talking about graphing exponential growth of functions. And our objective for today's students will be able to graph and use exponential growth functions to predict sports equipment costs in like an example or exercise 40. So the first thing you need to know is what's an exponential function? And an exponential function is a graph of the form y equals some value for a times b or base b to the x power. The reason why we call it an exponential function is because the variable is in the exponent. Okay, so that's why we call it an exponential function. A couple other things. A cannot be 0, and the base b has to be positive other number than 1. So it has to be positive and not 1. Okay? If a is greater than 0 and b is greater than 1, then the growth function y equals a times b to the x is an exponential growth function. Okay? B is called the growth factor, which is the simplest type of exponential growth function is the form y equals b to the x. So here's what we're talking about, the parent function. Just like we were talking last chapter about a parent function is the simplest version of that type of function that everything else is compared to. You've got this parent function of exponential growth. And an exponential growth looks like this here. So anytime you've got any number to the 0 power, it's 1. So that means anytime x is 0, that point here is going to be 0, 1 every single time. The second value, we'll say that's whatever the value of b is, because I don't know what it is. That point will be at 1, b, whatever that is. And from there, it will grow. So it will look like this. Okay, now when I've got negative values there because of these negative exponents, remember a negative exponent is a fraction, so it just keeps getting smaller and smaller and smaller as that negative exponent gets smaller, but it never crosses that this line here. So this is called an asymptote. Okay, so the x-axis is an asymptote. And an asymptote is a line that a graph approaches but never crosses. And for that parent function, the domain is all real numbers. We looked at that before, all real numbers. That means any value of x can go in there. But the range is always going to be greater than 0 because it's got to be positive. So let's talk now about, since we know what a parent function is, let's talk about those transformations of the exponential growth function. So remember before we talked about if something was being multiplied, okay, so if something's being multiplied in front, we know that it's a vertical stretch if a is greater than 1, or a shrink if a is less than 1, meaning a fraction, okay? Also, this outside here, because it's outside of that parentheses of x, we call that a vertical translation or slide. If it's positive, it's up. If it's negative, it's down. And here, because it's inside that parentheses with the x, remember that's a horizontal translation or slide. But it's funky town because it's inside that parentheses. So if it's negative, it actually goes to the right. If it's positive, it goes left. Okay, so let's say, for example, you want to graph this function of y equals 2 to the x. So let's go ahead and make a table. So that's our step 1. We're going to make a table. Let's pick some values of x in here, like -2, -1, 0, 1, and 2. We're going to plug that into y equals 2 to the x. So we've got 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 to the 2. So remember, a negative exponent tells me it's 1 over whatever's left over. So 1 over 2 squared is 1/4. 1 over 2 to the 1 is just 1/2. 1 over, excuse me, not 1 over. Anything to the 0 power, remember, is 1. 2 to the 1 is just 2, and 2 to the 2 is 4. So if I'm going to graph this, I'm going to plot those points now. So step 2, you're going to plot your points. So keep in mind, this point here is when x is -2, y is 1/4. When x is -1, y is 1/2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. So we're going to plot those points. Here's -2 up 1/4. So let's say that this is 1. Here's 1/2. And 1/4 is kind of like in the middle of that. At -1, it's up 1/2. At 0, it's up 1. At 1, it's up 2. So if this is 1, here's 2. And at 2, it's up 4. So here's 3, 4. And so when we connect our dots from left to right, a smooth curve. So step 3, you're going to connect from left to right, a smooth curve. So here we go. From left to right, it looks like this. So we're not zigzagging. And it's going to keep going. Remember, we said it's going to keep going towards that asymptote at the x-axis. Okay, so let's go ahead and say, okay, how would I graph this? So keep in mind, this is our function. This right here is that thing in front. So pretend like there's a parentheses around this. This is a vertical shrink by a factor of 1/2. So if I were to graph this really quickly, remember, we're going to graph the parent function, which would be 4 to the x. So if I plug in at 4 to the, if x is 0, that means we know anything to the 0 power is a value of 1. So there's my point right there. If I put 4 to the x equals 1, that's 4. So 2, 3, 4. If I put at x equals -1, that's 4 to the -1 is 1/4, and so on. So we've got that graph. Looks like this. Okay, so these are the points at -1, 1/4, 0, 1. That wasn't very good. And 1, 4. Now, we're going to graph this with a shrink by a factor of 1/2. So every value, we're going to shrink it by 1/2. So here, there's a distance of 1. So a shrink at that point would be 1/2 of that. Here, there's a height of 4. So 1/2 of that would be 2. okay? And then here at this point, it's a height of 1/4. So half of that would be 1/8. So I'm going to go ahead and graph those now. So do you see how my y equals 1/2 of 4 to the x? So we graph the parent function first, and then when you know that it's a transformation of a shrink by a factor of 1/2, we can take each point and shrink it down. So this last graph that we're going to do, we see here, this is our parentheses, right? So I can say that I know this is a vertical stretch because it's in front. It's bigger than 1, so we know it's a stretch by a factor of 4. So it's 4 times taller. I know this back here is a vertical translation because of our note that we took before, which means a slide, and we're going down 3. And then this right here, remember it's inside the parentheses. On the x, we know it's a horizontal translation. Remember, we're in funky town now, so that horizontal translation, instead of -1 going to the left, that's actually going to be right 1 unit. So let's go ahead and graph first that parent function, which is this right here, 2 to the x. So we're going to graph really quickly y equals 2 to the x. So remember, when x is 0, that is a value of anything to the 0 power is 1. So this is our point right here, 2 to the 0. I can write this down on a chart too. When x is 0, 2 to the 0 is 1. When x is 1, 2 to the 1 is 2. When x is -1, 2 to the -1 is 1/2. So let's go ahead and graph that. So here's my points. Here's -1. So that's my parent function. Now let's graph our new function, okay, where we're going to go stretch by a factor of 4. Okay, so everything's gonna quadruple. Okay, so if my height is 1/2 times 4 is 2. So this point now moves right here. It's gonna be 4 times taller. This point here has a height of 1, so I'm going to go up to 1, 2, 3, 4. That's my new height. And then this right here has a height of 2, so I'm going to go 4 times that, which is 8. So 5, 6, 7, 8. And this is my new function. Now I'm going to take that and I'm going to move everything to the right 1 and down 3. So this point here, I'm going to go to the right 1 and down 1, 2, 3. To the right 1 and down 1, 2, 3. To the right 1 and down 1, 2, 3. And those points are my new function. Right there. Okay, let me clean this up a little bit. All right, I'll see you, and we're going to finish up the rest of notes in class.